We are still we are still on organic reactions, and this time around we are going to talk about esterification reaction. An esterification reaction is a reaction between alcohol and carboxylic acid, and the reaction conditions we are using concentrated sulfuric acid H2SO4, and heat is applied. In our case, we are forming ester, and in addition to that, we'll get water, which is the inorganic product there. So let's pick one or two example in order to explain how this reaction is formed. We are using ethanol. Let's use propanol. 1, 2, 3. Let's use propanol. So here I'm using propan 1 all or 1 propanol. And regarding the case of the carboxylic acid, let me use a different one. Let me use ethanoic acid. And this is the functional group OH, which is the carboxy group. This is the carboxy group, which is the functional group of carboxylic acid. So if you are given a reaction like this is ethanol. If you are given a reaction like this under this condition, sometimes you also see something like this, just to show that is acid catalyzed. And remember that the concentrated sulfuric acid here is acting like a catalyst. It's acting like a catalyst. And in the other way around, is just basically a dehydrating agent. It removes the element of water from both reactants. It removes the element of water. And what happens is that the ones that will be removed from the alcohol group, the hydroxy group. From the alcohol group, remember the name of this functional group. We call it hydroxy group. And here we call it carboxy group. So the OH here, and from here we remove the hydrogen. Those are the ones that's going to be removed, and once two of them have been removed, this and this will combine together. They will be used to form water, and that is essentially what the concentrated sulfuric acid is doing. The the other one will be a question of joining this one with this one. So writing a esterification reaction should not be difficult, because if you look at it here, mostly what I'm doing now is this. I write this one first, which is the ethanoate path, So the hydrogen here has been used to form water. So in addition to that, I'm going to have, so I'm having this one now, which is coming from 1, 2, 3, which is coming from the ethanol. Then, and this one represents the hydrogens there. Hydrogen. Always be very careful to make sure that you add all the hydrogens, not to miss any of them. So in addition to this, we are forming water. And also another thing to look out for in this reaction is this: if you're asked to write the structural formula, to write the equation in form of structural formula, make sure you show all the bonds, including this one. Make sure you show all the bonds. You can see here I didn't show the bonds here, but if you are asked to write everything in terms of structural formula, so here I expect you to write something like this to join to this. And here we are applying heat. So if you look at it here, you will see if these two react together, they lead to the formation of ester. And the ester I'm forming in this very case will be propyl, which is the propyl is the alcohol path, and propyl ethanoate, which is propyl ethanoate, and we get our product, which is water. So, and I also want you to notice the pattern which happens here, which the patterns here, the alcohol part will form the propyl, the carboxylic part will form the ethanoate. Let me give one or two more examples. This is the first one. The second one, let's say for example, we are given butanol. One butanol, for example, is reacting with methanoic acid. This is alcohol. This is the carboxylic acid. Our product here, immediately you're supposed to know, our product here should be butyl methanoate, obviously plus water. Another one, I want you to understand the patterns. Another one, if we are given methanol plus propanoic acid, the product here should be methyl propanoate. And I think that it's worth also mentioning that, remember because some of you will be wondering why are we getting this, remember when we talk about the homologous series, ester, it is also called alkanoate under the IUPAC system of naming. They call it alkanoate. So that's why if you look at it here, methyl propanoate, butyl methanoate, and water obvious. So if we are required to show all the bonds, let's show all the bonds. The conditions here is concentrated sulfuric acid, which is usually used as a catalyst. So in essence, it's removing the element of water to form the water, and then the remaining one, the ethanoate one, and this will also join together. This is a simple reaction that you cannot afford to miss in exam.